Alright, so today we're going to be modeling a pulley in FreeCAD. It's this timing belt pulley 3414 series from V-Slot, Poland. So first, start FreeCAD. This is FreeCAD 0.21, latest version. I pulled from the FreeCAD website today. So the first thing you'll want to do is go to Tools, go to Add-on Manager. You're going to want to get the Gears. FreeCAD Gears Workbench. I've already installed that, but for you, if you're new, it'll be an install button up here. Press install. It'll prompt to restart FreeCAD. Say yes, restart FreeCAD, and then you'll get back here. So now let's actually start modeling. Create new file. Now save it. Always save consistently with FreeCAD. FreeCAD likes to crash. We just deal with this. So timing belt 3414. I've already modeled this before, so I'm going to copy file. The name is copy. Now let's start modeling. So timing belt pulley. So let's go into gear. Let's find what do we do to get a timing belt pulley. That'll be this button. Timing gear. Click that. Now, going in timing gear, bottom left, here are your settings for this timing gear object. We want type. This is a 5mm HTD pulley, so the closest we can get is GT5 in this. GT5 means that it's 5mm pitch, which is what we want. GT5, now, you can see 5mm pitch. What else do we have? We have 24 teeth. Teeth, 24. Okay? Now, let's take a look at the technical drawing. This will tell us it is 9.3 millimeters wide. So the height here becomes 9.3. Alright, this is good. But now, our gear, it's the bottom face of the gear. This face is sitting at 0. We want the center of the gear to sit at 0. So we're going to pull the whole thing down by 9.3 divided by 2 millimeters. We go to position right here, base placement position, negative 9.3 over 2, negative 4.65. We can input simple formulas into FreeCAD like 9.3 over 2 and it will solve them. Right, now our gear is in the right place. Now let's start modeling the next part. Let's model this disc that's on either side that keeps the belt in the correct place. Okay, so now we're going to go to part. We're going to create a part. And now we can go to part design. We can create a body. Now let's select this face and create a sketch on it. Make independent copy. Do the recommended option, it's fine. Now to make this is the disc, so we'll select a circle. Right, grab the circle in the origin, 0, 0. Now constrain the circle's diameter. Click this button over here. Here we go, diameter. We want the diameter to be 40.4 millimeters, so 40.4 millimeters. Okay, that has been constrained. The sketch is good. Now we exit. Now, attachment engine part has null shape. Even though we selected the face, it still doesn't know about what face it should be attached to. So, attachment editor. Select this any. Select this face. Okay. Now it knows what face to attach to. Now, save. Alright, now that we have saved, we can continue. We grab this sketch, go from part design into part, extrude. Okay, how long? Does it say? Yes. There's 9.3 on the inside, 12 on the outside. So we want 12 minus 9.3 divided by 2. So we put in exactly that. 12 minus 9.3 divided by 2. Alright, we have now extruded. And it extruded 1.35 millimeters. Does that sound right? Let's see, 9.3 plus 1.35 on each side. That's going to be 2.7. 9.3 plus 2.7 is, yes, 12 millimeters. Okay, that's good. And now we've created this disc, but only on one side. Let's add the disc to part. Alright, just pull that extrude into part. Okay, now this is good, but we need to make another one on the other side. Rather than modeling that again, I'm going to mirror. So what we do is we go here, go to Link Actions, Make Link. This created a virtual extrude. So this is not another part, this is just a link to this part. We can now mirror this. So we go press the mirror button, mirror extrude 001. We want it on the XY plane. That's the flat plane. So when it mirrors across the XY plane, it will mirror on the other side of that component. Base point 000, that's good. Press OK. Now we have mirrored to the other side. Alright, this is good. Now we can drag this extrude 001, mirror number 1, in here. Now, let's create the holes. First, let's think about the holes that go all the way through. So we will create another sketch on this surface this time. We go to Part Design, Create Sketch, Make Independent Copy. Alright, here we are. Now we have two different sets of 4 holes. First, let's tackle the holes on the top, bottom, left, and right. Create circle, put it here on the top, here on the bottom, here left, here right. Okay, now we can see that the distance of the holes to each other is defined like this. 16 millimeter, kind of diagonal like this. So that means that we need to be able to constrain that distance. So let's put in some construction lines. So I'm doing GN to get to construction. And then we select Create Line, here to here, here to here, here to here, and here to here. All right. Now, I can press E to make these lines equal, and press E to make these lines equal. Don't do the 4th line, because that's too much constraining. Just do the 2, a pair like this, and then a pair like this, and this. Now, they're starting to get even. We need a little more work. We need to make sure these are perpendicular. So we select this, and press N. Now they are perpendicular. Now these are constrained, and the top, bottom, left, and right. Now let's think about what is the size. That's 16 millimeters. So we select this. We're going to constrain the distance. So KD, distance, 16 millimeters. Right, that matches the drawing. Now we want here 4 millimeters through all. All right. So we're going to select this, 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 and this. Select all of the circles. And we go over here and we select constrain arc or circle. Diameter. I'm going to put 4.1 millimeters. Since we're going to be 3D printing this, and 3D printers aren't exact, so this will give it a little breathing room, so to speak. All right. Now we have our holes. For the top, bottom, left, and right. Now let's work on these 4 holes. Same kind of thing. Let's get out of construction mode. So I press GN again. I grab these, put a circle here, put a circle here, put a circle here, put a circle here. All right. Now press GN to back into construction mode. Select line, line down here, line over here, line up here, and line over here. Notice these lines have become perfectly vertical. It will constrain lines to vertical or horizontal if they're close enough. If they're not close enough, then it won't automatically do it, but you can do it manually. So I'll select this and press H. Now it's horizontal. I select this line. I press H. Now it's horizontal. Now these make a square. All right. Now next, what happened? Something happened here. I can't move this back and forth. It can only move up and down. There's a constraint here that got put in. Let me delete that. It automatically inserted a constraint that made this line tangent to this circle. Sometimes it does that. Sometimes it adds constraints you don't want. Just select them with the mouse and press the delete key. That will delete the constraints. All right, next, we know that these are 16 millimeters between those, 16 millimeters tall. So we select this, press I for vertical distance, 16. All right, now we want to make it square. So we select this line, we select this line, we say E, now they are equal. All right, now it's a square. But now we want to make sure that it is centered at the origin. So now I'm going to use some more lines to do that. So I can grab line tool again, here to here, line tool, here to here, right? Line tool, here to here. All right. Now we select this line, and this line. Make them equal. All right. Now that's constrained. It can't move anymore. Now we select all these 4 circles and see what radius do we want. We want the diameter, rather, M4 by 0.7 millimeter threads through all. So since I'm 3D printing this, we can't 3D print threads. The printer doesn't have that kind of accuracy. What we can do is print it a little too small. And then when you screw in the screw will dig its own threads. So we see M4 threads. So we're going to constrain arc or circle. The diameter should be 3.9. That way the screws have something to grab on. All right. Now we've created all the holes we need. Now we save. All right. Now close this sketch. Now go over here. Same deal as before. Sketch 001. Attach an editor. Any. Select the face you want. Okay. Now our sketch is here. Now we grab this sketch and we're going to extrude again. All right. Extrude. But now we want to cut holes. So we're going to use this extrude to cut from the other extrude. So make this extrude very long. I'm going to make it 100. Make it symmetric. Now, when I apply that extrude, now we have these holes. They go through all parts of this pulley and much more. This is good. Now we can close. So now we have this extrude. Nope. Now we have this extrude here. We can add that to the part. All right. This is good, but we still have to worry about these. These 4 holes have a 7.2 millimeter counter bore. So we need to make room for those. We need to make room for that counter bore. So to create a counter bore, we're going to create a hole, but that doesn't go as far down it. We will not go through the whole part. We'll just go through a small part of it. So we're going to create another sketch, and we're going to do another extrude. Now this is kind of getting in the way of us seeing this, so I'm going to press spacebar, and that decreases, that turns off visibility. The part's still there, we just can't see it. Now, go to part design, like we did before. Select this, select the face, create sketch, make independent copy, okay. Now we're in the sketch again. All right, top, bottom, left, and right. Turn off construction mode, create circle, top, bottom, left, and right. All right, grab all of these, go up here, constrain. Now we wanted diameter 7.2 millimeter counter bore. I'm going to do 7.3 millimeters. Give the 3D printed part a little bit of spacing so we know everything will fit correctly. Now we go into construction mode, GN, select line, center to center, center to center on all of them. Okay. Now these 3 equal. These 2 perpendicular. Now you've constrained it a lot. Now the distance again is 16 millimeters. So constrain distance 16. Now close. Now make sure the sketch is attached correctly. Attachment editor, any, this face, okay. Now there's a place for our holes, all right? Now, with our sketch, we go to part. Now we go to extrude. Now we don't want to extrude up, we want to extrude down. So length along will be 0. Now we want length against. It goes down 4.1 millimeter depth. So we go here, and this will become 4.1 millimeter depth. Apply. Close. We can't see it because it's embedded in the part, but it's there. Let's add that to the part. Now, all the parts of what we need are here. Now let's put them together. So we're going to use Boolean operations. That means we're going to be combining parts together and cutting parts out of other parts. Let's see how we can do this. Select time and gear. All right, now I'm using Control-click here to select multiples. Select the extrude. Select extrude 001, mirror number 1. We've selected all the parts that we want to be in there. Now we do union. This combines parts together. Now we've created a union. Now let's see, did that work? Why aren't they all selected? Time and gear, extrude 001. All right, they're all there. I think it worked. Now we're going to cut out the part that we don't want, which is this extrude and this extrude, which I'll make visible. So now we grab this part and this part. Now we make a union of these. Now this is all of the parts, all the areas that we don't want to have in the eventual model. So we select this fusion. Now we select this fusion, and now we do a cut. All right, what's up with this? This is a plane. This is a plane that was used for creating those cuts. So we're going to press space to turn off visibility. Now we can see the part we've just created. Now we have a part with all these holes in it. But wait, we forgot something. Look in the middle. We have a nice big hole in the middle that we don't have here. So let's add to that. Select the cut. Go here. Fusion 001. That's the part that needs to be cut out. Extrude 002. All right, that's the parts that go all the way through that get cut. So now we select this sketch. We're going to go in and we're going to add the circle that we missed. Let's take a look. All right, 14 millimeter bore. So get out of construction mode. Select circle. Put in the middle. Go out. Now, constrain the arc. Let's do 14.1 millimeters. Give it a little bit of space for that 3D printing accuracy. Close. And look at that. We have now added the 14 millimeter bore. Let's take a good look at that. Take a good look at what the actual part looks like. Looks pretty similar, okay? I'd say the part looks pretty good. All right, save again. Now that we've created the part that we want, now how do we actually 3D print it? We're going to select this. We're going to go to Mesh mode. Now we push this, Create Mesh from Shape. We've selected the cut, Create Mesh from Shape. Leave these settings at the default for now. We can talk about those later if we want to, but the default settings are good. Okay. Now we have cut meshed. This is the mesh version. So this is a bunch of polygons and points that represents the model. Now we press Export Mesh. All right. Now it'll give you cutmesh.stl. That's a crappy name. Let's give it a good name. With timing belt 3414 copy. And it does the .stl for you. So just press save there. Now save the file again. Now we can go in here. Now we see timing belt 3414 copy.stl. Now you can send that to somebody. You can print that yourself. You're good. So we've gone start to finish. We got from a website with a technical drawing and some words, the description of it, and now we have an STL file ready for printing.